Okay, here's a common ion question. It's going to flip it on its head just a little bit. It's asking you what pH would copper 2 hydroxide start to precipitate from a solution if the copper concentration is 0.001500 molar. And that's an interesting question. So if we have hydroxide that's insoluble, remember that there's both hydroxide ion and H plus ion present in water. And based on the pH, those two concentrations are varied. And so there would be a pH when the concentration of OH is too high and it has surpassed the molar solubility limit. And so then that would start to precipitate and form a solid. So we still need to think about the equilibrium that represents the dissociation of copper 2 hydroxide. So copper 2 hydroxide separates into copper 2 and 2 hydroxide ions, still with no initial concentrations. But we're going to say that we're 0.0015 and 0 here. And so what we're going to try to figure out is what's the molar solubility of CuOH2 when it's at this particular concentration of copper 2. So when we figure out what those two what the molar solubility is, then we'll have an idea of what the concentration of OH minus at that solution can be. Any more OH will cause CuOH2 to start to precipitate out of the solution. And so we're going to figure this out from the same sort of common ion question. We'll get 0.015 plus X for copper and 2X for the concentration of OH. We still want to use our equilibrium expression to solve for X, but again, we got to deal with that X in the parentheses, so we'll try to drop it and see if it's small enough to do that. So after I do that, I get 0.0015 times 4x squared. Then I get 0.006 x squared. So I end up with x equals 2.83 times 10 to the negative 9th. Now that is in fact pretty small compared to 0.0015. It's several orders of magnitude smaller, certainly less than 3%. Okay, now X is the molar solubility. Remember, that's not necessarily the concentration of hydroxide. The concentration of hydroxide is 2 times the molar solubility. And that's the maximum amount of hydroxide that can be present. So now now we have an understanding of what the concentration of OH can be before things start to precipitate, but we have to multiply that X by 2. So I end up with 5.66 times 10 to the negative 9th. That's the maximum molarity. And so if I figure out the pOH, I get 8.25, and that leads me to a pH of 5.75. So the pH of 5.75 is the highest pH that the solution can be at before copper 2 oxide starts to precipitate if the copper is 0.0015 molar. Okay.